A person's walking on stilts that always remain parallel. So what we've established straight away is that there are parallel lines, okay? So that's great, that's good news. If they're parallel lines, what does that mean you're allowed to use? You can use alternate angles, okay? Now next thing, are joined at the point T. T is the midpoint of both braces, so what does that mean? PT equals and then QT equals TR. There's many different ways to do this one. I see a way of using ASA, and I also see a way of using SAS. Okay? Yes?
When the lines cross both angles in the middle between T, like angle PTQ and...
They're vertically opposite angles.
Yeah.
So I'm going to say, so what we're going to use is, so I under PTQ or PQT, I'm only allowed to use angles and lengths from PQT. Does that make sense? Will you dim the lights there, or knock them off even? Right? And under SRT, am I allowed to use angles and lengths from SRT? Is that okay? Now, the first one I'll do is I'll do SAS. What do I mean by SAS? I mean side, angle in between, and side. Is that okay? So let's go for it. Angle 1 equals angle 2. Why? Okay. Okay. Next thing we're going to go for is PR. Sorry, PT is the same length as what? ST. What's the reason? T is midpoint of PS. Does that make sense? And then, so now I have S, A, and what's the last letter I'm going to need? S. Okay, and what can we do here then? QT equals TR for the exact same reason, but we have to write it differently. T is midpoint of QR. Is that okay with you guys? Yes?
When you're doing like SAS, do you have to like find side, angle, and side, or could you find like side, then angle?
Yeah. I'm just, as a maths teacher, I'm a bit OCD. I like it perfect in order, you know. You'll see me in the videos, I actually rearrange it so they're in order. But look, you can still, you should be able to get away with that. I just don't do it that way. Alright, now, the other way of doing it, I'm not going to do this formally, but the other way to do it would be angle 2 equals, angle 2 equals angle 3, why? Alternate angles. And what could you have done then? You could have said angle, and the side in between, and you could have got ASA very quickly, couldn't you? So you have SAS and ASA. Give it a go myself now, right? Alright. ABCD is a parallelogram with diagonals AC. So, and X and Y are points on AC. So X and Y are points on AC such that ABX, which is A to B to X, which I'll call angle 1, is the same as CDY, which is angle 2. Prove that ABX, which is the small triangle in the bottom left, is the same as the CDY, which is triangle on the right. Now, here's what I'm thinking we do. Alright, we just accumulate information and then we try and prove it formally in a second. So what I'm going to say is angle 1 equals angle 2. What's the reason? Given. We know it's a parallelogram. So what would that automatically mean? Angle 3, sorry, I don't actually need that because that's actually outside the triangle, isn't it? What about angle 3 and angle 4 and 5 and 6? What can we say about the two of them? Right. Angle 3 equals angle 4 and angle 5 has to equal angle 6. For what reason? Diagonal what? Diagonal bisects 6 corner angles in parallelogram. Is everybody cool with that? Parallel. How do I spell parallelogram? It's LL.
Or
P-R-E-L-O.
Oh, it's up there. No excuse.
I was just reading that off.
Yeah. Oh, if you're not sure how to spell something in a test, look at the rest of the test, and sometimes you find the word spelled properly for you elsewhere. Huh? Do your best. Alright. Now, diagonal bisects corner angles in a parallelogram. Everybody on board with that? Now, what could I say about I think we have this under lock now. What can I say about angle 4 and angle 5? Angle 4 and angle 5?
They're equal.
Why are they equal to each other?
Alternate.
Yeah. So I can actually do that twice. I can say angle 4 equals angle 5. And what's the other combination of that? Yeah, 3 and 6 as well. Now you understand, if you don't get it completely right, you've already got a lot of marks there, haven't you? Because you've listed what you know. Okay, you haven't put it in any order yet. Alternate angles, okay? So, what does it follow then? This is now the purple writing. Let's look at both triangles. Can I say angle 6 equals angle 3?
yeah.
Why?
Ultimate angles.
Oh, so I have it, don't I?
Yeah.
So, if I was to do this formally, what I'd say is, if I do it in the corner, I'd say angle 1 equals angle 2, that's given. Yeah? And then I say, what did I say? Angle 3 equals angle? Because they're alternate, is it?
Yeah. And then line AD would equal to line.
Yeah, exactly. Alternates. And so that's A, and that's an A, and if I slot an S in the middle, I'm in business. What two S's would be the same? Yeah, AB and DC are the same because they're opposite sides in a parallelogram. Yeah, that's it. Just give me a sec. I just want to write it down for me. AB equals CD, and the reason for that is, I'm not going to write it, but you should have it in here. They are opposite sides in a parallelogram. This means their two triangles are congruent by AS, A. And I'll pause and then I'll take questions. Next one. BXDY is a parallelogram. Now where's BXDY? Right, so BXDY is this one here. Sorry, I'm wrong. BX.
No, you're right, and then you correct the X and the B.
That one.
Yeah.
Woo.
You already
Okay.
got the two angles, and then
Yeah, we know X.
Alright.
Well, we know X and D and X, B, and D.
Relax. Chill. Once again, I find these questions quite tough, as do you. So I need processing time. Alright. So, what I'm aiming to do here is, I'm aiming to prove for me, I'm not saying the way you're doing it, I'm saying the way I'm doing it, is I'm currently thinking that this purple triangle, I'd love to prove that the purple triangle is exactly the same as the green triangle. If I prove that those two triangles are identical, parallelograms are comprised of two identical triangles. And that for me would seem to be a very, could be a way to get that done. Alright? Now, here's what I'm going to start off with. Alright? Now, what we already proved was, we've already proved that ABX and CDY are, what are they again? We've already proved that they're the congruents. Therefore, I can use BX is the same as DY. BX is the same as DY. Reason being, what do we call it? Corresponding sides. Do you know what corresponding sides means? Alright. So essentially, corresponding side means something like this. Imagine I have one triangle, alright, and we call it, for argument's sake, A, B, C, and that's 10, that's 12, and that's 5, alright? And then we come along, I replicate this, and I bring it over here, alright? And instead of having the same letters, I use different letters, like X, Y, and Z. And what I would say is that BC corresponds to YZ because they're the same angle they're the same length of side looking at the same size of angle. Do you get what I'm saying? So that's what corresponding sides means, okay? So corresponding sides and as ABX, triangle ABX is congruent to triangle CDY, what we proved in part 1. They also have a common side, don't they? What's the common side? Common side is XY. So I have XY equals XY, and all we have to write down there is what? Common side, alright? Now here's the hard part, alright? I'd love to prove that this angle here, angle 7? I'd love to prove angle 7 equals angle A. That would give me an ASA, wouldn't it?
Yeah.
Now, yeah.
Because we know that triangle ABX and DCY
Yeah.
are the same. Angle 7 and 8, they're both in a straight line, so you can say. So if you put in angle 9 and 10.
Excellent. Perfect. Gotcha.
It's like 1, 3.
Perfect. Angle 9 and angle 10. You see angle 9 and angle 10? Okay. What we say is angle 9. We can say angle 9 equals angle 10 because this time they're corresponding angles of the two triangles, aren't they?
Yeah.
Excellent, Connor.
Could you say congruent triangle for that one as well, though?
Yeah, corresponding angles in two congruent triangles. Is that okay?
Yeah.
And therefore, we're going to put them into a straight angle next, aren't we? We're going to say that. So, Connor, because I'm a bit OTT, I'm going to drag this downwards. All right. So, right. Now, what am I going to say next, lads? Angle 7 plus angle 10 equals what? Angle 8 plus angle 9. And what's that? Straight angle. Therefore, what can we say next? Angle 7 equals angle 8. And what can we say then? Triangles are congruent by. Now, what two triangles are we talking about?
XYB and DXY.
XYB and DXY, yeah? XYB and what's the other one?
DXY.
Congruent. Hence, what's the parallelogram then? XB dy is a parallelogram. Alright. Now, how many people believe they wouldn't have got part 2 out in 10 minutes? Wouldn't have. Yeah?